You guys have your 2.4 to 2.8 test tomorrow, all right? We're going to start chapter 3, Wednesday, Thursday, Friday. We're going to come back from Thanksgiving, finish up chapter 3 stuff, and test. Our next test will be Thursday when you guys come back. All right, once we get back from Thanksgiving, you guys have like 2 weeks before we start to get ready for midterms. So make sure you're on top of things. If you're missing something, get it done this week before we leave. All right, first questions are talking about average rate of change. Anybody remember what our average rate of change formula is? You guys have a seat, please. What is your average rate of change formula? Y2 minus Y1 over X2 minus X1. Guys, it's very important that Y's are on top and X's are on the bottom. Okay, very important. Now, when you're given average rate of change problems, sometimes you're given equations and you're given X values and then you're figuring out the Y's. In this case, you're given a graph. So you're given two X values, and you have to figure out what the Y values are based upon the graph that they gave you. So for number 1, I have the X value -4, and I have the X value 0. So let's figure out what our ordered pairs are. Where X is -4 on your graph, what is the Y value? 0, good. And where X is 0, what is the Y value? 1, all right? Simple enough. And now we're going to find the average rate of change. Y is on top, X is on the bottom. So I'm going to say 1 minus 0. If I start with 1 in the numerator, what do I need to start with in the denominator? 0. So 0 minus -4. So this becomes, all right, so 1 minus 0 in the numerator is 1. 0 minus a -4 is +4. So your average rate of change is 1 over 4. That's it. So if we're now looking between X is -2 and where X is +2. Well, if where X is -2, guys, what is your Y value?
2.
Where X is -2, 0. And then where X is 2, what is your Y value? 2. So again, we have our 2 points. So I'm going to say 2 minus 0. My Y is on top, and then the X is on the bottom. If I started with 2 on the numerator, I need to start with 2 in the denominator. So 2 minus -2. 2 minus 0 is 2. 2 minus a -2 is 4. And we always simplify. What does that reduce to? 1/2, 1 over 2. Good. So your average rate of change between those two intervals is 1 over 2, or 1/2. So now between where X is -3 and X is +4. Guys, remember, this is due tomorrow morning, so it'd be in your best interest to be doing this with me. Not just watching. All right. Where X is -3, what is the Y value?
3.
+3, okay. And where X is 4, what is the Y value? -3, okay. So our average rate of change, I'm going to say -3 minus 3 on the numerator. So I'm going to say 4 minus -3 in the denominator. What is -3 minus 3? -6, good. And then what's 4 minus the -3?
7.
+7. So you guys, be careful. Some of you make a silly mistake and say, put your 3's in the wrong spots or something like that, and you tell me it's 0. Make sure your negatives are right, all that good stuff. All right, moving along. If we're talking about odd, even, neither, algebraically. Odd, even, neither, algebraically. How do I do this? Where do I look first? Highest exponent, great. So number 4, I see 2 exponents. Which one is the bigger one?
X.
The 3, x to the third. So this function could be one of 2 things. Either odd, since that's an odd number, or neither. Odd or neither. Plug in any number you want bigger than 1, and it's exact opposite. I'm going to use 2 and -2. So I'm going to plug in -2, and I'm going to plug in +2, and I'm going to compare the answers. If I think this function is odd, what are the answers going to be of each other? Opposites, okay? So if I plug in -2, guys, just take your time, use parentheses. 6 times -2 cubed minus 5 over 2 times -2 squared plus 7. So as we simplify, exponents first, what's -2 cubed? -8, good. And then -8 times 6 is -48 minus 5 in the numerator. In your denominator, you have -2 squared, which is 4. 4 times 2 is So 8 plus 7. What is negative 48 minus 5? Good. Negative 53 over what? 15? 8 plus 7 is 15? Okay. So I'm going to come over here and do the exact same thing, guys. But I'm going to plug in a positive 2. So I have 6 times 2 cubed minus 5. And then 2 times 2 squared plus 7. Exponents first. 2 cubed is 8. 8 times 6 is 48 minus 5 over 2 squared is 4. 4 times 2 is 8. So 8 plus 7. So what's 48 minus 5? 43 over 15. Guys, are those two numbers exact opposites of each other? No. So your answer here is neither. All right, look at number 5. This is not written in standard form. Don't just assume the first exponent. We look for the what? The highest. The highest exponent is a 4. What kind of a number is 4? So this is either even or neither. Again, any number and its exact opposite, bigger than 1, I'm just always going to stick with 2 and negative 2. If I think this function is even, what are the answers going to be? The same. Same numerical value, same sign. So let's go and evaluate. I have 2 cubed plus 2 times 2 to the 4th power minus 2 squared. Some of you like to put it in standard form, fine. Some of you like to always do the negative first and the positive second, fine. But if I have 2 cubed, 2 times 2 times 2 is 8. 2 to the 4th power is 16, and 16 times 2 is 32. Good. And then I have minus 2 squared is 4. Work left to right. What's 8 plus 32? 40. And then 40 minus 4 is 36. Good. So same thing over here. Just plug in a negative 2. So I have negative 2 cubed plus 2 times negative 2 to the 4th power minus negative 2 cubed. So negative 2 cubed is negative 8. Negative 2 to the 4th power is 16 times 2 is 32. Minus negative 2 squared is 4. So again, we're going to work from left to right. What's negative 8 plus 32? Negative 8 plus 32. 24, positive 24, okay. And then 24 minus 4 is 20. Are those two numbers the same? So your answer is neither. Some of you on your quiz just wrote odd. I didn't, even if it was right, I didn't give you any credit. You have to show me. It says algebraically. You've got to show me algebraically. All right, on our quizzes, for the most part, you guys did really well in our transformations, which was really nice to see. Remember, negative signs, depending upon their placement, changes things. So in this first one here, for number 6, I have a negative out in front. What does that negative out in front tell me? Reflect where? Good. Reflect over x. You have to tell me which axis. It's a reflection over either x or y. If you just tell me reflection, you're not going to get full credit. This 4 right here, out in front, is a what? It's a vertical, good, stretch. By how much? By 4. I need to know if it's vertical or horizontal.
Do we have to write by 4?
Yes.
Let's take it off.
Tell me what it's by. What about plus 7? 7 left. So you could tell me left 7. Remember, anything inside is the opposite of what you think. And then what is this minus 9 here? Down 9. Tell me the direction and how much. Okay, good. Now, scooting on over here, I have a negative sign out in front, but where is that negative sign? It's inside, so this is a reflection where? Good, reflect over y. I have a whole number being multiplied, but it's on the inside, so it's really a what?
Shrink.
What kind? A horizontal shrink by how much? By 1/5. Very good. Very good. Now that plus 8 is on the inside. What does that tell me? Left 8, great. And then what is plus 1? Up 1, good. Good, good, good. For the most part, you guys were really good with the transformations. All right, questions on page 1. All right, moving along. Moving along. I made one little change. Sure. All right, I made one little change on number 11. Take the X out and put in a 3. I just want to do a different kind of problem. Now, these compositions and combinations, guys, they look similar with the way that they're written. So you need to understand what the question is asking. I'm not going to tell you tomorrow, is this what you mean? No, you guys have to tell me that. Numbers 8, 9, 10, and 11 are all combinations. You're adding, subtracting, multiplying, or dividing. The other ones are compositions where you're taking one function and actually physically plugging it into the other. So in the case of number 8, you have 2 parts to this question. You're going to simplify it, you're going to combine it, then you have to state the domain. So if I look at number 8, I have the f function plus the g function. And it says to leave your answer in terms of x. I'm not plugging in any numbers. So my f function is 3 minus x squared. And I'm adding it to the g function, which is 1 over x squared minus 4. All right? If you're going to add fractions, they have to have the same what? Denominator. Okay? So what's going to be a common denominator between 1 and x squared minus 4? X squared minus 4. So I'm going to have everything over x squared minus 4. This first fraction needs the x squared minus 4 on the bottom. What you do to the bottom, you do where? To the top. Great. So this is just multiplication. You're going to FOIL. What is 3 times x squared? 3x squared. What's 3 times negative 4? Minus 12. Negative x squared and a positive x squared is minus x to the 4th. And negative x squared and a negative 4 is plus 4x squared. All right, we have this written over the same denominator. We're good to go. Now the last thing we have to do is combine like terms. So I have x squared minus 4 is my denominator. My highest exponent I see is 4, so negative x to the 4th. I can combine 3x squared and 4x squared, right? And get 7x squared. Awesome. And then minus 12. So there is your combination. You added the two functions together. That's what you got. Now you have to state the domain, right? This is where we go back and we say, are there any domain restrictions? There's 3 rules. First rule, no variable in a denominator. Second rule, no variable underneath the square root. Third rule, combo of those two, right? No variable underneath the square root in a denominator. So what rule is this breaking? The denominator. So what do you have to do? Set it not equal to 0. So I'm going to say x squared minus 4 equals 0, or cannot be 0. Some of you could do this in your head. Some of you cannot. But if I'm going to solve this, I have x squared cannot be 4, so I do what? Take the square root. So x cannot be what? Plus or minus, good, plus or minus 2. So your domain is I can use anything in the whole entire world except for negative 2 and positive 2. If that's hard for you guys to think about or to visualize, put it on a number line. Here's negative 2, here's positive 2, here's 0. I can use anything but, so that means I'd have open circles there. I can use anything over here, I can use anything in the middle, and I can use anything over here. So how would you write that in interval notation? Okay, so I have negative infinity to negative 2 in parentheses. Union. Perfect. Negative 2 to 2, and then 2 to infinity. Sometimes, guys, we miss that negative 2 to 2, miss that middle part. So it might be in your best interest to go ahead and graph it so you actually see it. But there's 2 parts to those answers. Question?
Anything with the 1 that you're adding, or is it just
Where?
The 1 over.
Oh, I didn't add that, did I? Oh, yeah, this would be plus 1 here, so it would be negative 11. You're right. Sorry. I forgot about that. Yeah, this would be 11. Thank you, ma'am. There you go. All right, go to this next one. What am I doing? Multiplying. Am I plugging a number in for the x values? No. I'm multiplying g and h together, and I'm keeping my answer in terms of x. This says keep your answer in terms of x. So the g function is 1 over x squared minus 4. And I'm multiplying that to the h function, which is 4x plus 7 over 1. This problem appears much harder than it is. How do you multiply fractions? Straight across. Straight across. Good. Keep, change, flip is when we divide. So if we just multiply across, what's 1 times 4x plus 7? It's 4x plus 7 over x squared minus 4. That's all you can do there. That's it. You can't cross out x's. That x squared is attached to the negative 4. They have to stay together. You can't cross out one of the x's in that, and then with the x in the 4, it does not work like that. But am I breaking any domain rules? Yes, I'm breaking the same one as the first one, right? So what are the two numbers that x cannot be? Positive and negative 2. So your domain is going to be negative infinity to negative 2, negative 2 to 2, and then 2 to infinity. Same denominator, same rules being broken. Questions? All right, let's go on down here. What are you doing with f and g? You're dividing. So you're going to take the f function, just as it's written, 3 minus x squared, 3 minus x squared, and you're dividing it by the g. Is that the 1 over? Yeah. 1 over x squared minus 4. Heaven, how do you divide fractions? Keep, change, flip. Perfect. You're going to keep the first one. I'm going to change to multiplication, and then I flip. So guys, when I do this, watch. It's 3 minus x squared times, when I flip 1 over x squared minus 4, what does it flip to? X squared minus 4, just like that, right? Can you multiply those two things together? Yeah, we've already done this actually. So I have 3 times x squared is 3x squared. 3 times negative 4 is minus 12. Negative x squared and positive x squared is minus x to the 4th. And then negative x squared negative 4 is plus 4x squared. And then we combine what? Like terms. So negative x to the 4th plus 7x squared minus 12, because I combine those two. That's it. We divided those two things together. Now, what is your domain? It's all real numbers. Negative infinity to positive infinity. Why did Camilo know that so easily just by looking at it? We're not breaking any rules. There's no variable in a denominator. There's no variable underneath the square root. And there's no combo. There's no variable in a square root in a denominator. All right, I changed this one just because it worked out so gross, and I wanted you to see something like this. How is number 11 different? Change your in terms of x to a 3. How is number 11 different the way that I'm doing it? There's a number. So what kind of an answer should I get? A number. All this is saying is everywhere you see an x, plug in a 3. So I take my g function. What's g again? I should know this by now. 1 over x squared. So 1 over x squared minus 4 divided by h, which is 4x plus 7. Now, if you want to go ahead and keep, change, flipping all that now, you can. I think it's easier to just plug in the number and then evaluate. So I'm going to rewrite this as 1 over 3 squared minus 4 divided by 4 times 3 plus 7. Let's just keep evaluating this. What is 3 squared? 9. So I have 1/5. You guys agree? It's a funny looking 5. Divided by, well, 4 times 3 is 12, and 12 plus 7 is 19. This is over 1, correct? I can say 19 over 1. Guys, how do you divide fractions? Keep, change, flip. So 1/5 stays. Change division to multiplication, and we flip. 1 over 19. What's 19 times 5? 95. So your answer is 1 over 95. If you have a number in those parentheses, that means you're going to get a numerical answer. You guys with me? All right. All right, last page. How is this different? No, you don't have to give domain if you're evaluating with a number. Yep. I changed that problem from the original. What are these questions? Why do they kind of look the same, but they're not? You're taking one, good, and plugging it into the other. These are compositions. You're not combining them. You're not adding and subtracting. You're actually taking one whole function and putting it in the other. Remember, I told you guys, work from the inside out. So I'm going to take this g function, and I'm going to plug it into the f function. If you need to, go like this. Take the g and plug it into the f. It might make things a little easier for you. So you have your 4, and then instead of x, I'm going to write 5 minus x squared. Then I have minus 2. Now you simplify. What do you do first? Distribute. 4 times 5 is 20 minus 4x squared minus 2, right? What can I combine? The 20 and the negative 2. So you have negative 4x squared plus 18. 20 minus 2. Right? That's all you can do. That is the composition. That's taking the g and putting it in the f. Now, do you have any domain restrictions? No. You can use anything you want. It's totally fine. So your domain is negative infinity to positive infinity. So now we're going to do the next one. Now I'm going to take the f function. I'm going to work from the inside out. And I'm going to plug it into the h. So I'm taking 4x minus 2, and I'm plugging it into 3x minus 1. So I have 3. Instead of x, I'm going to plug that whole f function. So 4x minus 2. And then I have minus 1. Distribute. 3 times 4 is 12x. Not squared. Just 12x. And then 3 times negative 2 is minus 6 minus 1. So this becomes 12x minus what? Perfect. Domain? All reals. Negative to positive infinity because there's no rules being broken. Everybody good? All right, the next one, when I was typing this up, that random 1 went in front there. I mean, even if it was there, all it would mean is just times 1. But this is the exact same type of question. It's just written a little differently. Does this say g times h? No. If this was g times h, it would look like this. Do you guys see the difference? This is saying take the h and plug it into the g function. So you're taking the h and plugging it into the g function. So 5 minus, instead of x squared, I'm going to write 3x minus 1, and then I finish and I have quantity squared. This is just an algebra problem, guys. What do I do first? That says 3x minus 1 times what? 3x minus 1. That minus sign stays out in front. Don't even worry about it yet. So you have 5 minus, what's 3x times 3x? 9x squared. 3x times negative 1 is minus 3x. Negative 1 and 3x is minus 3x. Negative 1 and negative 1 is a plus 1. So I have 5 minus 9x squared minus 6x plus 1. Do you notice, guys, how I kept that whole thing in a parenthesis? Why? Why did I do that? I have to distribute that negative. If it was a plus sign, you didn't have to. But I have to distribute that negative sign to everything back here. So I have 5 minus 9x squared plus 6x minus 1. And now you can combine like terms. Negative 9x squared plus 6x plus what? 4. Any domain issues? Nope. So it's again negative infinity to positive infinity. How are we doing? Everybody okay? Okay, we're using the same functions up at the top here, but we're doing something a little different. I'm going to finish these up and then we're done. What is 15 asking you to do? Plug negative 2 into the f function, figure out your answer, and then what do you do with that answer? You plug it into the g. It's 2 really basic problems in one. You work from the inside out. So the first thing I'm going to do is I'm going to find f of negative 2. F of negative 2. Well, what is my f function? 4x minus 2. Okay. So I'm going to replace the x with a negative 2. So I have 4 times negative 2 minus 2. What's 4 times negative 2? Negative 8 minus 2 is negative 10. Now I'm going to take negative 10 and do what? Plug it into g. So I'm going to find g of negative 10. What's the g function? 5 minus x squared. So again, careful with your signs, guys. You have 5 minus negative 10 squared. What's negative 10 squared? 100. So 5 minus 100 is? Negative 95. So this whole thing is negative 95. Work from the inside out. Number 16, I'm going to work from the inside out. I'm going to first evaluate g of 3. So g of 3, the g function, 5 minus x squared. So 5 minus x squared, 5 minus 3 squared. 5 minus 9 is how much? Negative 4. I take negative 4 and I do what? Plug it into h. So I'm now finding h of negative 4. 3x minus 1. All right. So I have 3 times negative 4 minus 1. What's 3 times negative 4? Negative 12 minus 1 is negative 13. So my whole answer for this composition is negative 13. Everybody with? All right, you guys doing great. We're almost done. Holy moly, what's going on in 17? Miss Meadows lost her mind. I'm going to plug 1 into, take it step by step. Just find h of 1. H of 1. My h function is 3x minus 1, right? So I say 3 times 1 minus 1. 3 minus 1 is 2. Now what do I do with 2? I'm going to take 2 and I'm going to plug it into the g function. So I'm going to find g of 2. That's x, or 5 minus x squared, right? Yeah? Okay. Before I get to the end, you guys are like, you didn't write the problem right. So I have 5 minus 2 squared. Well, could I have made this any easier for you guys? 5 minus 4 is? All right, now what do I do with 1? I'm going to take it and plug it into f. So I'm going to find f of 1. What is f? 4x minus 2. So 4 times 1 minus 2. 4 minus 2 is 2. So the whole composition, f of g of h of 1, is what number? 2. You're just working from the inside out. Questions? Finding inverses algebraically. The first step is the most important. Inverses, guys, if something is an inverse, it's the opposite, right? We know that. We've known that for a while. So if we're going to find our inverses algebraically, f of x is just a fancy way of saying what? Y, okay? So this is just y. In order to find the inverse algebraically, the first step you have to do is switch the places of the x and the y. That's the first step. You rewrite this as x equals 7y squared plus 6. Now, once you've done that, you just solve for y. But if you don't switch the places, then you're not finding the inverse. How would I now go about getting y all by itself? Subtract 6. Okay, I'm going to subtract 6 from both sides. Agreed. So you have x minus 6 equals 7y squared. Now what? Divide by 7. Good. I'm going to rewrite so it says y squared equals x minus 6 over 7. And then what's the last step? Take the square root. When you guys physically take an even root, square root, fourth root, sixth root, what goes in front of your answer? A plus or minus. Only if it's an even. If you take the cube root, it's not. But my answer is not complete because you have to use inverse notation. Function notation is f of x. So inverse notation is f negative 1 of x. Whatever the letter is with a little negative 1 up there, you have to have that. And then it's plus minus the square root of x minus 6 over 7. Now, algebraically means you're showing me all these steps. What you guys can do, because a lot of you like to check, and that's great, you can compare your original to the inverse. Everything should be switched, should be opposite. So if you notice, in the original, you are multiplying by 7. You see that? What are we doing in the inverse? Dividing by 7. In the original, we were squaring x. In the inverse, what are we doing? Taking the what? We're taking the square root, the radical. In the original, we were adding 6. In the inverse, we're doing what? Subtracting 6. So everything should be switched, should be opposite. Right, now we're talking, 19 says g of x. It doesn't matter. It's still in function notation. This says y equals 7 minus 5x squared over 4. The first step, what do you have to do first? Switch x and y. You have to switch the x and the y. So this says x equals 7 minus 5y squared over 4. Now you go about undoing. What's the opposite of divided by 4? Okay, times this side by 4. We times this side by 4. So 4x equals 7 minus 5y squared. What's the opposite of a positive 7? So subtract 7. Good. 4x minus 7 equals negative 5y squared. Trying to get y by itself. Divide by negative 5. Great. Again, I'm going to rewrite so my variable's on the left. So y squared equals 4x minus 7 over negative 5. And then how do you get y by itself? Take the square root. If I put the square root on, what goes in front of my answer? Plus or minus. So I have inverse notation g negative 1 of x equals plus minus 4x minus 7 over negative 5. And again, compare your original and your inverse. In the original, I had a 7, positive 7. In the inverse, I have a negative. Hang on one sec, Ozzy. In the original, I had multiply by 5. Yeah? I was multiplying by negative 5. In the inverse, I'm divided by negative 5. In the original, I was squaring x. In the inverse, I'm taking the square root. And in the original, I was dividing by 4. In the inverse, I'm multiplying by 4. Ozzy, question?
We know that everything's going to be inverse. Why do we have to do all the math?
Say it again?
We know what the inverse is going to be. Why do we have to do all the math? Couldn't we just look at the polynomial of the inverse? Because did she say it's like the exact opposite of what it says there?
I mean, I think it would be very hard to get it all in the right spot, but if you're proving it, it says to find the inverse algebraically, correct? That means you have to show me using your algebra. If it was a multiple choice and you could just figure it out like that, that's one thing. But I wouldn't try to do it all in your head. You're going to make a mistake. H of x. Same thing as saying y, correct? All right. So we're going to switch the places of x and y. Once we switch the places of x and y, we can go ahead and solve. So I have square root of 2 plus y. First thing I'm going to do is subtract 6. Great. Subtract 6. Like stuff like this, Ozzy, is why that's hard to do. So 2 plus y. All right. Now what? Square. Guys, when you square, what are you squaring on the left-hand side? Are you squaring just the 6? You're squaring the entire thing. It's x minus 6 quantity squared. So you are left now with 2 plus y equals x minus 6 squared. How do you get y by itself? What do I do with the 2? Subtract 2. You cannot combine here, y'all, the negative 6 and the negative 2. That negative 6 is in a parenthesis being the whole quantity squared. And I have minus 2. Is this my complete inverse? What am I missing? Okay, I started off with H, so I'm going to use H. Guys, if you just use F every single time, that's fine. Because this is what I'm looking for. If you don't use the same letter I did, not that big of a deal. I have to have that little -1. So this is going to be x minus 6, quantity squared, minus 2. And again, compare your original to your inverse. In the original, we were adding 6. In the inverse, we're doing what? Subtracting 6. In the original, we had the square root. In the inverse, we have squared. In the original, we were adding 2. And in the inverse, we were subtracting 2. So, ladies and gents, tomorrow is your test. Please make sure, try to be here. If you are not here, there will be one makeup opportunity. And if you do not take the test on the makeup day, you are getting a 0. There will be one makeup opportunity this week for the test if you are not here tomorrow. Does everyone hear me? Okay, just make sure.